In this video I'm going to try a Ninja Physics calculation. I'm going to try and estimate whether it's feasible to blow pollution out of cities. So the basic idea is you have your city with your buildings and it's under some thick layer of pollution, like for example the bushfire smoke in the 2020 bushfires in Canberra, or the pollution caused by stubble burning in New Delhi, or many sorts of pollution in China. And it has been proposed, amongst others by the Indian government, that what you do is you build very big fans and blow the pollution out of the city. Is this actually feasible? Now, like most Ninja Physics questions, there's not a simple answer to this. It's going to depend what sort of pollution, what sort of city. My gut feeling is this is going to be very difficult, so what I'm going to try and estimate is, could it work in the best possible situation? Because if it can't work there, it's not going to work at all. If we find it is feasible in the best possible situation, then we can look at harder and harder situations. So what's the best possible situation? Well, let's assume that the pollution is quite a narrow level trapped below an inversion layer, which is often the case. So there's a thick layer of pollution trapped quite low over a city. And we'll also assume that the pollution is only over the city and not over the surrounding countryside, which wouldn't apply, for example, in bushfire smoke or stubble burning in India, but might apply if the pollution's from cars or something like that. How can we get rid of the pollution? I guess there are two ways you could do it. As usual for Ninja problems, there are multiple ways, and it's important to spend the time early on to think about the different ways and work out which is the most sensible one. One way would be to have some sort of horizontal fans spinning around like this, which blow the pollution up. This would only work if it's a narrow pollution inversion layer, but then might mix the polluted air with the cleaner air above. It won't get rid of all the pollution, but might reduce it a bit. The other possibility is to have horizontal fans that would blow the pollution out sideways, and maybe more fans on the side, and so to get a constant stream of clean air coming in from outside, which once again would only work if the air really is clear outside the city. So let's pick one of these. I think we'll pick the horizontal, and let's estimate some sizes. I know this inversion layer, the layer of polluted air, when I climb Mount Ainslie in the morning, often you're above a layer of cloud and fog and smoke, so that means when you're 200 meters up, you're above it, so that might be about 100 meters thick. And a city, I don't know, let's assume it's a small city, so about 10 kilometers across, and let's assume it's 10 kilometers square, roughly speaking. Okay, so how are we going to estimate this? I mean, we could talk about numbers of fans and things like that, but maybe a simple step would be, how much energy is it going to take, how much power to blow the smoke out of the city, and is that actually feasible? If the energy is just ridiculously high, then it doesn't really matter how many fans you got and what the design is. If the energy is low, then we can start wondering about whether you need so many fans, it's going to be too expensive. There are many things that could go wrong, but energy is usually a good first step. So let's estimate the mass of all the pollution over a city. So that's going to be a cube, maybe 10 kilometers. 10 kilometers, 100 meters. So that's going to have a volume of around, that's 10 to the 4 times 10 to the 4 times 100. That's about 10 to the 8, 9, 10, 10 to the 10 cubic meters. Density of air is about 1. Kilogram per cubic meter. So that means the mass is around 10 to the 10 kilograms. Now, we can work out the energy needed to accelerate that to a particular speed, half mv squared. What speed do we need? Well, I guess it depends how rapidly we want to get the pollution out. I guess what we need here is we need to be able to move it out on the timescale with which it's generated. So if, for example, it's being generated by cars and a rush hour will pollute the city, then we need to be able to get it out on the sort of timescale of a rush hour, so maybe about an hour. If the pollution takes weeks and weeks and weeks to build up, then pumping the air out in a day or so would be okay. So let's assume it's a slow build-up of pollution. So the basic idea here is that if it's a very stagnant air pool, the pollution will build up over a long time, and so getting it out fairly slowly will help get rid of it. Whereas if the pollution is generated very fast, then we need a much faster fans. And again, I'm trying to err on the side of making this easy, the easiest possible situation, because I think it's going to be very hard, and if even the easy situation doesn't work, we know it's impossible. Okay, so let's say we want to remove the pollution in a day. That means we need to go this distance in a day. So the velocity equals 10 to the 4 meters over 24 times 60 times 60, which comes out as about, so it's 10 to the 4, 60 sub 60 is 3,600 times 24, so that's about 10 to the 3, 10 to the 3, 10 to the 4, about 10 to the 5. So that's about 0.1 meters per second, very roughly. Again, we're after an order of magnitude figure. So the kinetic energy is a half mv squared equals a half times the mass, which is 10 to the 10, times 10 to the minus 1 squared, which is going to be roughly, we'll ignore the factor of a half, it's the least of our approximations here, so that's about 10 to the 8 joules. Now 10 to the 8 joules over a day, it's, well, a day is this many seconds, about 10 to the 5, so that's about 10 to the 8 over 10 to the 5 watts, about 10 to the 3 watts, which actually isn't very much. I mean, that's what it takes to run a microwave oven, about 1,000 watts. So, actually, this is looking feasible energetically. The power needed to move the air is not that great, because while there's an awful large mass of air, we don't have to get it very fast to clean it out in a day or so. It's a rather gentle, slow breeze to get it out. So under these approximations, which is a slow build-up and the pollution only in the city and not in the surrounding countryside and blowing it out sideways, power consumption isn't so bad. We're going to need a lot of fans, so that might be the follow-up question. How many fans would you need to actually make it work? But on energy terms alone, it's not looking unfeasible. Now for the write-up, just need to make sure that we've explained what approximations. We've explained the approximation about the slow build-up of pollution. I just need to explain blowing air sideways. And assume pollution in city only. And that's probably a clear enough explanation so that someone else, another physicist, could understand what we're doing.